clusters, resource pools, DRS, and HA. So this is sort of part 2 of our series on resource and performance management here in our ESX Nugget. And what we're going to do in this section is actually take what we learned in the last section and apply it to something that is a little more usable to us. And I'll admit, in the last section we talked about these great alarms and how you can look at and watch for performance information and keep an eye on it. But really what you want by buying the enterprise version of ESX is the ability for the system to kind of do some of the work itself. You can play the role of systems babysitter, and playing that role as systems babysitter is part of what you need to do as an administrator for ESX. But there's also some built-in tools that will allow you to have the system kind of babysit itself in some ways as well. And those are the concepts of clusters and resource pools and DRS and HA. And we're going to talk about all of these in this nugget. And hopefully when you were scratching your head at the end of the last nugget about, well, wait a minute, I've got to watch this thing incessantly. Well, you're going to find out that there are some ways that you can implement in distributed resource scheduling so that the system will load balance various virtual machines across itself as needed, so you don't have to worry about it so much. This nugget will also talk about HA, which is high availability, so that if you lose one of your ESX chassis, bam, it just dies. The systems in that chassis will automatically reboot on other hosts so that you will not lose those machines for a very long period of time. So let's actually first talk about what are clusters and resource pools a little bit. And just like with a lot of the other nuggets, I want to show you a picture of those of this capability. So let's say we have 3 ESX servers, and each one of these ESX servers hosts a number of systems. Okay, I'm going to drop here. There's the first one, there's the second one, there's the third one, right? If I have, let's say, I have 4 virtual machines sitting on the first server, and I have 2 virtual machines sitting on the second server, and I have 3 virtual machines sitting on the third server, right? This is probably not, assuming all these virtual machines use the same resources, this is probably not the best distribution of load in my environment. And me as an administrator, it's probably difficult for me to interpret the performance graphs to really understand why this is a bad idea. I just know that having 4 and 2 and 3 is probably not the best way of doing things. Now, what a cluster is, what a VMware cluster is, it is essentially taking these individual hosts and abstracting them, taking a layer of abstracting about each of these hosts. So instead of thinking of these hosts as individual hosts now, we go one more step further into thinking of them as a collection of processor and RAM resources. So what I do is I kind of bundle these systems into a cluster, a VMware cluster. And this is not anything like a Windows cluster or any of the other clusters you think about where you've got systems that are working with each other. This cluster actually is a way of listing a bunch of physical resources all in one group. And then once I group them as a single group, I no longer really worry about them in terms of whole numbers, in terms of the amount of resources assigned to each of the individual systems here, but instead I think of them as the collection of resources. So let's say this machine has, I don't know, 500 megahertz. That's a really low number, but we'll just call it that. And this one has 500 megahertz, and this one has 750 megahertz, right? And this one has 4 gigs of RAM, this one has 2 gigs of RAM, and this one has 8 gigs of RAM. Well, doing the calculations of what the processor speed and what the memory rate is, the memory count is for each of these systems, grows actually rather complex as you get these dissimilar systems that we've got into our environment. By creating a cluster, we can then add in some complicated math that VMware can do to identify how much of the resources we're using and whether we are appropriately balancing the system across those resources. What we then gain is by knowing what the total system resources is, in this case it would be 500, 500, and 750, so 1750 megahertz. And then also the total amount of RAM, so 8 and 2 is 10 and 4 is 14 gigabytes of RAM. By knowing what the total amount is across the entire infrastructure, we can now divide out our virtual machines based off of the resources that they're consuming. You know, this machine down here has a lot more RAM and processor use on it. Maybe we don't necessarily need to load balance so it's 3, 3, and 3. Maybe the best positioning of this machine may be to move it down to here because this is a lesser machine than this is over here. And the reason why it has 2 hosts hosts on it is because that's the only the amount that it can support. So it allows us to use the mathematics engine that VMware has built to better identify and assign our resources into the hosts that they should be in. Now, the concept of load balancing here inside of VMware is called DRS, or Distributed Resource Scheduling. And what DRS is it's a combination of essentially vMotion plus mathematics. So you take the vMotion, which is the ability to move the systems around without turning them off, and then you add in a bunch of math, and the math says, okay, I'm going to move you around based on where the resources are the best. And then now you kind of take a lot of the brain work and a lot of the difficulty out of doing the proper load balancing of your VMware cluster. We also have one more technology, which is sort of DRS, but in an OOPS standpoint, this is a concept of high availability. And all high availability is there's really not so much math associated with high availability. What high availability says is if we lose that system, then we know that we have to get these 4 machines rebooted somewhere else in our environment. But we want to do that while we're still following the rules that we set up with our distributed resource scheduling. And so this one may move over here, and this one may move over here, and this one may come down here, and this one may come down here, or however they end up getting divided out. Those systems will be rebooted onto the existing servers in the infrastructure while still following the rules that we've set up with DRS. So this is kind of the picture that we've set up with VMware clustering and HA and DRS. Let's actually go and talk about it and put it into practice with our existing infrastructure. So here's our hosts and clusters, and here's our data center that we've created. Here are the 2 systems inside of our data center. We have one data center here. We have 2 hosts, and we have 2 virtual machines. In a data center, for us to be able to use HA and DRS, the first thing we need to do is create a cluster. So let's go ahead and do that now. We'll call it Nugget Cluster. And to do that, we also need to enable the cluster features of HA and DRS. Once we enable these, we're going to be able to make use of HA and DRS inside of our environment. Now, we have a couple of choices we have to make whenever we enable them. For DRS, we have the ability to manually, partially automated, or fully automated do the movement of machines across our available systems in our cluster. If we choose manual, Virtual Center will suggest the recommendations for those virtual machines, but won't actually move them for us. If we choose partially automated, those virtual machines will be automatically placed onto the hosts at power on, but we won't actually move them once they've powered on. If we choose fully automated, the system will actually vMotion those systems, those virtual machines, back and forth across all the systems in our cluster as it sees fit. And we can choose whether or not we want to do it fairly often or not so fairly often, or how often we want to actually move those systems across based on recommendations. What I find typically is a lot of people will start out with the manual mode. And once they gain comfort with how VMware is actually doing it and the suggestions that it's giving, then we move into this concept of partially automated, so that whenever we bring machines on, it will put them in the right place. And after a while, you realize, well, I'm tired of getting notified about these recommendations to move virtual machines across. I just want to let it do it itself. And then around that point, then we switch it over to fully automated. So let's go ahead and choose manual for this point, so we can just see what the migration recommendations are for our virtual machines. But I think you'll find that as you use the system and begin to trust the vMotion capability from a production sense, you'll eventually end up moving your environment to a fully automated mode. And what you'll find also is that when you move into that fully automated mode, the thought processes that you'd had as far as putting machines in certain locations, you'll find that it'll actually move them into different locations because your manual process is probably not as optimized as its internal automatic process. Also with HA, we have a couple of decisions as well that we have to make. We can determine the number of host failures allowed before we can, the number of host failures that are allowed, that the cluster failure will allow. This will reflect the amount of spare capacity you want to ensure for the cluster. And also, do you want to start virtual machines if they violate the availability constraints or not? So what this says is if you've lost one of the machines in your environment, let's say you have three ESX servers in your environment and you lose one of them, but to move those virtual machines off of the lost host onto other hosts would actually violate the availability constraints or would oversubscribe the amount of resources for that system, do not start those virtual machines. So really it's kind of a trade-off. Are you more concerned about seeing your machines up? Or are you more concerned about seeing your machines performing appropriately when you have a failure? And that's really up to you. If you want to make sure that your machines are always up, They may not be performing fast, but at least they're up. Then you choose the bottom button. If you're more interested in seeing the existing virtual machines performing to their standard performance, then you choose the top button. I'm going to choose the bottom one here because I want those machines to power on. Even if they're going to be not performing very well, I still want them to power on. I click next here and then finish, and that begins the creation of the cluster. And you'll see here this cluster gets created down here. Once we create that cluster, what we actually need to do is drag some of our systems into that cluster so they can become part of that cluster. I'm going to click on this system over here and I'm going to drag it into the Nugget cluster. There's the first one. As soon as we drag that system into the cluster, we're going to be asked about resource pools. And what we need to do in terms of the resource pool is whereas the cluster is the boundary of the systems in our data center that we want to concatenate together, resource pools are actually subdivisions of those clusters that are put together for the purposes of assigning resources to various things. Now that's a lot of words to explain something that's really simple, really. Think about it like this. Let's say you have a group of developers, right? And you have a group from the IT department, and you got a group from HR. And these three groups have all chipped together to buy a virtual infrastructure, but they want to make sure that they get equal parts of their virtual infrastructure. Remember now that you're no longer dealing in terms of individual machines when you create these clusters. Instead, you're dealing in resources assigned to those machines. And so what you want to do is you want to split up your virtual infrastructure, your ESX environment, into 3/3 because all these people chipped into the same pot to buy the box, or buy the whole environment, really. What you can do now is you can create resource pools and assign a certain amount of resources to the developer group. You can assign a certain amount of resources to the IT group, and you can assign a certain amount of resources to the HR group. Give them permissions to use those resources, and you're off to the races. We'll talk a little bit more about resource pools when we get into user permissions, but for now, just assume that resource pools are subdivisions of clusters. In this case, when we create our cluster, we can put all of our initial hosts, virtual machines, into this cluster's root resource pool. If we don't want to create those resource pools yet, we can just use the root resource pools, and that is just assumed to be all of the resources for the cluster. If we want to create a resource pool, we can choose this button down here and create a resource pool and give it a name. In our case, we're not yet going to actually create resource pools yet, so we're going to put it all in the root resource pool and click Next. We say we're ready to complete. We click Finish, and you'll see here that our system moves from where it was up in the Nugget data center down to below the cluster. I do the same thing with 102. If I move 102 into the Nugget cluster, I can put it into the resource pool as well. And you'll see now that the difference is that we have our systems, our host systems are now sitting sort of at the same level as our virtual machines are. Our virtual machines are not sitting underneath our systems like they were before. They're sitting at the same level of the systems because once you create the cluster inside of your data center, once you create that cluster, you really have gone as far as you possibly can in terms of abstracting the resources on those systems. At this point, you really don't care anymore where your virtual machines are located. You just want to know that they're appropriately located based off of your DRS rules. So now that we've understood how to create the cluster, let's talk a little bit about how we would create our DRS rules. You'll see here initially that we're having some configuration issues on our system because as we're doing the initial DRS calculations on our system, we are seeing that we have insufficient resources to satisfy an HA failover level on this cluster in our data center, and we're unable to contact a primary HA agent. One of the reasons why we have insufficient resources is because this 192.168.0.102 server does not have enough memory available in it so that it can host both Nugget 1 and Nugget 2. It's got 919 megabytes, of which 381 are unavailable at this point. And so what you're going to notice initially is that if you try to create a cluster that has not enough resources in it to support that HA, you're going to begin to get notified initially. So before you have the failure, you can either add RAM, or you can add systems, or you can add whatever is necessary in order to support all of the needs of the resources for that cluster. This is a very good thing because now you know that you're not going to be able to survive a failover because the DRS calculations are telling you. Let's go ahead and just ignore this for just a moment, and we'll get back to it in just a minute. But let's actually talk about again about these DRS rules and how we'd want to set up DRS rules for the systems in our environment. So in order to set up our DRS rules, let's go ahead and right-click on our cluster here and choose Edit Settings. Now, the first thing we're going to see here is a couple of additional options in addition to what we've seen before when we created the cluster. If we go to VMware HA, we'll see the number of host failures allowed, and we'll see our admission control. What we see down here in terms of virtual machine options, it gives us a little bit of additional extensibility in terms of what we want to have our machines do whenever we lose a host in our cluster. So you'll see here, for a particular virtual machine, here's Nugget 1. If we lose the host that Nugget 1 is currently on, what is the priority for restarting Nugget 1 onto another machine? If Nugget 1 is perhaps a domain controller, for example, or something that's very, very important to us, we may want to make sure that that is restarted first before anything else if we lose a host. We also may want to say, okay, if we actually have a situation where one of the hosts in our cluster loses connectivity with the rest of the cluster, maybe it's got a network that goes down, or maybe some sort of network traffic impedes it, or for some reason it gets isolated from the rest of the cluster, what do we want to happen whenever that host actually loses connectivity? Do we want to power off this particular virtual machine, or do we want to leave this machine powered on in the case of an isolation event? If we want to leave it powered on so we can still have the machine running in the case of an isolation, we may want to do that. If we want to power it off so we don't have any kind of concern about machines getting restarted elsewhere, we can do that as well. So we have the ability to choose what our restart priority is, and our isolation response here is associated with high availability. In terms of DRS, here's our automation level again, like we saw before, but we may want to be able to create some rules associated with that DRS as well. Now, there are really two types of rules that we can create here with DRS, and those rules are what we call affinity rules and anti-affinity rules. And what affinity rules are is rules that say, I want to make sure that two virtual machines always stay together. So if one needs to move to another host because of a DRS a trigger is caught, then go ahead and move its connected machine with it. An anti-affinity rule says, conversely, maybe I want to make sure that two machines are always separated. Now let's think about this. Why would I want to keep two machines together? Maybe I have a system thread, for example, a web server connected to a business logic server connected to a database server. And if I keep them on the same ESX server, then all of their network connectivity stays very close together as opposed to separating them out amongst different hosts. So in that case, I may want to keep those virtual machines together on the same host. Conversely, if I have maybe two domain controllers, if I lose a host and then I have to reboot both of those domain controllers, well, then I don't really have domain services while those two domain controllers are being rebooted. So I want to make sure that those two domain controllers are separated so that they never sit on the same ESX host. And I can do that by creating separate virtual machines here. Once I choose what the name of the virtual machine rule, my machine rule, and I can choose separate, and then I can add in the hosts that I want to add in as part of this virtual machine list here. Now it's important to know that you want to try to create as few rules as possible, because when you're doing your DRS calculations are based primarily on what the performance is. And the more times that I add in rules about this can't be with, Sally can't sit with Jimmy, and Jimmy always sits with Bill, and Bill can't be with Josh, and Josh always hangs out with so-and-so, as we add more and more of these rules in here, we find that we constrain DRS to the point where it can't do its job anymore. So the rule is about virtual machine rules is try to create as few of them as possible to allow DRS to do its functionality. If you try to get too complicated with how you create your rules, you may end up kind of screwing yourself in the end. Under virtual machine options, we have what kind of automation level if we don't want to do the global level for moving around these machines based on our DRS calculations. On a per machine basis, we can change what the default is for those virtual machines. Right now, do we want to do it with a global setting, or do we want to set perhaps Nugget 2 to fully automated so it's always working at full automation? We can do that here inside of virtual machine options. So this is the ability to create these DRS rules for our cluster here inside once we've created that cluster in our virtual infrastructure. Now, affinity and anti-affinity rules aren't the only way in which we can kind of enforce how we want our systems to move. In some cases, we may want to assign more or less resources to a virtual machine because we know that it's going to need more resources, or we know that it may try to use more resources than are available to it. So we want to try to constrain the resources that are available to that system. This is actually a really important part of managing your ESX infrastructure, is managing the resources associated to those virtual machines in that infrastructure. A lot of times, unless you have machines that you know need to be prioritized for resources or that you know can be resource hogs, you don't want to set these reservations and limits. And we'll talk about these in just a second. But if you have machines that are on the upper or the lower bound of resource use and you want to constrain them in some way, there is a mechanism here under resource allocation that you can allocate limits and reservations of resources to virtual machines. I'm going to right click on edit resource settings here for Nugget 1, and we're going to talk a bit about how we can kind of constrain Nugget 1. Maybe Nugget 1's being a little bad and we need to make sure that it doesn't go beyond its available amount of memory, or maybe it's not being good enough and we need to make sure that it gets enough always of available memory. First of all, you see up here on the top, we see CPU resources, and we can assign how many CPU resources we want to give to a virtual machine. Do we want to give it the normal amount of CPU resources? Okay, we're going to give it our normal, which is 1,000 shares. Do we want to set it to a high number of shares so that it gets more CPU resources than everyone else? Or do we want to set it to a low number of shares so it gets fewer than others? Also, if we want to get really crazy, we can customize the amount of shares that we give to our CPU resources and assign it based off of, okay, 1,000 here and 1,500 here and 800 there, and assign them all together. Now, if you choose custom CPU shares, it's going to get complicated because each time you add additional machines into your environment, it's going to have to add to the total number of CPU shares. You'll see here under shares value, I have 2,000 shares. Well, when I add a third machine, I'm going to add another 1,000 shares, and that kind of jacks with the assignment of value for shares there. So be aware that you can change these here to assign how much CPU resources you're going to give to a particular system. Now, you have also the option of choosing what reservation is and what a limit is for that CPU, for that virtual machine as well. If I want to make sure that this system always gets a minimum of at least 1,000 kilohertz, I can drag this little thing over here and set it to, I don't know, 1,026 megahertz here. This says that no matter what happens, when we get into a resource contention situation where I've got virtual machines that are vying for resources, then Nugget 1 will always have at a minimum 1,026 megahertz of available resources. Again, maybe this is your Exchange server that you want to make sure always has enough resources so that if somebody else spikes, it's never going to crash completely or lose performance completely. Conversely, let's say, oh, I don't know, I've got a web server that once in a while may get overly used. In that case, I may want to set the limit not as unlimited, but I want to reduce that limit down so that I can kind of slow down. Whoa there, Haas, slow down there. I want to make sure that you can't consume all of the resources on my server so that if you do end up in a spike situation, then you're not going to be pulling down all the virtual machines on that server all at once. So what I'm doing here, and this is the same thing down under memory resources as well, what I'm doing by doing this is preventing any particular host from consuming too many resources or not getting enough resources. You'll see here that the little triangle says those are the remaining resources that are available here for reservation. I can't obviously assign more memory than is available than is actually on the system. So as you begin to understand what the characteristics, the performance characteristics are of the systems on your network, then you'll be modifying these settings potentially to ensure that no system can consume more than its fair share of CPU and RAM. And this is a valuable, valid, important part of DRS because you need to do this to make sure, number one, that DRS can do its job and move systems around the way it needs to, but number two, that as it moves systems around, you don't end up in situations where hosts can't get enough resources or are consuming too many resources. Once you've got all of your configurations set, then you can go back in here into your Summary tab and take a look at how DRS is monitoring the environment and what DRS is seeing as part of your environment. And this is a nice kind of global view for your environment in terms of what it is seeing for utilization percentages. Up here on the top, we see HA and what our admission control is and what our failover capacity is and also what our DRS level of automation is. You'll see here a migration threshold, apply recommendations with 3 or more stars. Once we get to actually migrations where VMware will begin making recommendations on migrations, it will begin giving them a strength of the recommendation, if you will, starting from 1 star and up to 5 stars. And the strength of that recommendation will give you some idea of how important the DRS calculations it believes that it needs to move a VM virtual machine off of one host and onto another. And so we don't have any migration recommendations at this time, but as we begin doing calculations and as you have more more and more systems on your environment, you'll begin to see those recommendations. And you can set your threshold for where you want it to actually automate those migrations based on the number of stars or based on the strength of its conviction that it needs to move those. A little bit further down here, you'll also see a DRS resource distribution graph here that shows you of the number of hosts, what is the utilization percentage of those hosts. Is it looks like here we have one between 70 and 80% of memory and one between 40 and 50% and one between 80 and 90 and one that's really at 0% of CPU. Also in terms of percentage of entitled resources delivered, we're giving pretty much all the resources delivered to the number of hosts. So this gives us a view of what DRS sees in terms of its calculations based on the systems that are on the that are in the cluster, that are in the resource pool, and that also are being managed by DRS. Lastly, I want to go back to the error message that we saw just a little bit ago whenever we tried to create our HA part of our cluster here. And you'll see here that we have an HA agent that shows that we have received an error. And whenever you see these errors, whenever you're creating the HA componentry in your ESX infrastructure, there can be a couple of different reasons why they're being created. You know, if you're trying to enable the HA agent and some of the hosts are down inside of your cluster, that can be a problem. Or if there's network connectivity between the primary agent and the other agents in the cluster, that can be a problem too. One of the big issues that occurs, and that's why I wanted to illustrate this as part of this nugget, that ESX has a fairly substantial requirement on DNS in order for it to function properly. Obviously, all the hosts in your environment need to be able to see each other by fully qualified domain name for them to be able to send machines back and forth across the different hosts on your network. And so one of the problems we're actually having here is associated with the fact that there is no fully qualified domain name that this host can actually resolve to. If we bring up our, SSH to our machine and we try to say, okay, well, ping ESX nugget 1, we're actually not going to get a response because there is no response for ESX nugget 1. What we need to do is go into our DNS server, in this case it's Active Directory, and actually create another host record for our ESX servers, ESX nugget 1, and name it to 192.168.0.101. And then we also need to create one for ESX nugget 2 as well, ESX nugget 2 and 192.168.0.102. By creating these DNS records, now our hosts can respond to each other and communicate with each other not only by application, but also and by FQDN and IP address. They can communicate with each other across all of these mechanisms, which is a critical component for HA to function properly. Once you've made these changes and you know that you have good connectivity between your systems, you can right-click down here and choose Reconfigure for HA, which will restart the HA driver, the HA service on your hosts. Once the HA service is restarted and once the communication functions properly, then we should actually see our configuration issues go away on our hosts that are configured for HA. And once those configurations go away, then HA will function properly. And it appears that our HA reconfiguration is complete. You'll see here that now we don't have any error messages anymore, and so our servers are happily operating inside of the Nugget cluster with the HA componentry functioning fine. Remember, you do have to have that DNS functionality working so that all of the hosts can talk to each other not only by their FQDN and their IP address, but also by their host names so that the HA componentry works fine. So what have we talked about in this Nugget? We've talked about really kind of VMware 201, where we've taken VMware and we've added in a bunch of mathematics into VMware so that we can do kind of a smart VMware. So we can add load balancing and smart load balancing based on resource use into our environment. We talked about how ESX really is all about managing performance, and that now with the addition of DRS rules and the high availability that uses those DRS rules, we can automate some of the management of that performance. And then we talked about 4 elements of ESX: clusters, resource pools, DRS, and HA, and how we can implement them on our environment to help keep our uptime as high as possible. I hope this has been informative for you, and I'd like to thank you for viewing.